Hello, pre-calculus students, and welcome to our continuing lesson on zeros, real zeros of higher order polynomial. And in this video, we are going to talk about the factor theorem. And the factor theorem says that if x minus k is a factor of f of x, then we can say a few things. First, f of k has to equal 0. And this is actually something from the remainder theorem. Second, k is an x-intercept of f of x, meaning that if you were to graph it, if this is a factor, then k is going to be a factor. K is going to be an x-intercept of f of x. And so let's put the factor theorem to work here. So I have a couple of examples. This is f of x, this is g of x, this is h of x. And the question is g of x a factor of f of x? So this is a yes-no question, right? These are yes-no's questions. So we're going to use the remainder theorem and check if remainder is 0. Right? If it is 0, then it is going to be a factor. So we know that let's do this first problem here, is g of x. Well, in this expression here, remember that this is x minus -1, so k is equal to -1 in this case. So if we want to check, well, I'm going to call this part A and this part B here. So for part A, we can just go, what is f of -1? So type that into a calculator. So this is -1 to the third plus 2 times -1 squared minus 5 times -1 minus 6. And this is going to give you 0. So the answer here is yes for part A. For part B, let me use a different color here so we don't get everything all mixed up. This expression here, k is equal to 3, x minus k, so k is equal to 3, so we're going to do f of 3. So this is 3 to the third plus 2 times 3 squared minus 5 times 3 minus 6. This is 27 plus 18, so that gives me 45 minus 15, that gives me 30, minus 6, that gives me 24. So this is the remainder, and so the answer here is no. So now I have a factor here, okay? So now I know that I have a factor. I know that x plus 1, you can conclude from this point here, is that x plus 1 is a factor of f of x. Now, you can ignore the statement for this synthetic division for a minute here. We're going to continue this problem. We're going to say, well, I know that f of x is equal to x plus 1 times something. Times something in here. Okay? What is this factor? Well, if we want to find this, we need to do division. Okay? So in order to find this expression here, we need to do division. Do polynomial division to really find it. Okay. So let's do that right now. We know that we have x to the third plus 2x squared minus 5x minus 6. X plus 1 goes here, and whatever answer I get up here, that's going to go in here. Okay. So polynomial division, x to the third divided by x, that's x squared. Multiply this out, you get x to the third plus x squared. Subtract the quantity, you get x squared. Bring down the negative 5x. This is going to give you x. Multiply this out, you get x squared plus x. Subtract the quantity, you get negative 6x. Bring down this negative 6 here, and you are going to get negative 6. Multiply this out, you get negative 6x minus 6. This is 0, and the remainder should be 0. This remainder here, we know that it should be 0. So this is going to give me x squared plus x minus 6. Okay. Now then I can factor this even further, and I can say this is equal to x plus 1. That's this expression here. But x squared plus x minus 6, this can be factored again. So that factors into x plus 3, and then factors into x minus 2. So x squared plus x minus 6 factors down to this expression here. I'll make this a little bit bigger. Okay. So one of the things that we can conclude from this is that f of x has zeros at negative 1, negative 3, positive 2. And now we have, this is a function of degree to the third power, so we know the end behavior. We know the zeros. We can look at all these exponents here and see their multiplicities, and then we can use this entire expression here to solve a problem just like we did in the previous section, okay, and dealing with graphing and looking at behavior of higher order polynomials when they're factored. Okay. So the main idea here is when you're given something like this, and you're given some potential factor to check, well, you can check it first using the remainder theorem. That's pretty quick. If it's 0, then you know it's a factor, and so you can write it, you can factor it out. And if you want to find the rest of this expression, you need to do polynomial division to get it. And then if you have a quadratic in here, you can factor that down even further. Okay. So I'm going to end this here. Example 3 here says synthetic division, and in the next video, I'm going to show you a faster way to do this problem. It turns out there is something called synthetic division that makes this problem a lot quicker for us to do. Thank you for watching, and make sure you watch the next video.